Okay, Chapter 5. We start out with 5.1, which are fundamental identities, where we talk about our basic trig identities. And this starts us out with the reciprocal identities. And I believe we've talked about actually all of these identities we're going to look at today, but we're going to go back over them, and then we're going to start using them. Alright, so the first group we're going to talk about is our reciprocal identities. And you know the reciprocals. What's a reciprocal of cosecant? It's sine. And so cosecant of theta is equal to 1 over sine of theta. But then right below that, it tells us then sine of theta is equal to, well, we know then it's going to be the 1 over cosecant of theta. It's reciprocal. What's the reciprocal of secant? The reciprocal of secant is cosine. So secant of theta is equal to 1 over cosine of theta, which means cosine of theta is equal to 1 over its reciprocal, which is secant of theta. And then we have our tangent and our cotangent. So we know cotangent's reciprocal is tangent. So cotangent of theta is equal to 1 over tangent of theta, which means that tangent of theta is equal to 1 over its reciprocal, which is cotangent of theta. And so there's our 6 reciprocal identities. Now for the quotient identities, I believe we talked about these before as well. We use the fact, you already kind of know these anyways, because you know that tangent in terms of x, y, and r is really just y over x. And so remember, y is associated with sine and x is associated with cosine when we're just talking about on that unit circle. So tangent of theta is equal to sine of theta over cosine of theta. And then cotangent is just its reciprocal, remember? So we know it's x over y, so it's going to be cosine of theta over sine of theta. Now, all 8 of these that we just looked at, it doesn't matter if our trig functions are raised to the first power, if they're raised to the second power, if they're raised to the third power, we can still use these. So what I mean is, like if I said cotangent squared on this last one, it would be equal to cosine squared over sine squared. I'm going to write down a think bubble here. So if I said cotangent squared, we could say that that is cosine squared over sine squared. We just square them all. Whoops. I don't know why I put the parenthesis there. It's supposed to be a cloud bubble, my think bubble. Alright, same thing up here at the top. If for this first one, if I had cosecant squared, we would just say that that's 1 over sine squared. So we can do that on these first 8. Okay? But the Pythagorean identities are different, because the Pythagorean identities come from the Pythagorean theorem. And so therefore they always have to be squared. So you cannot change the next ones that we're going to look at. Okay, so for Pythagorean identities here, remember we know that x squared, let me change colors here because I just use this color. So we know that x squared plus y squared equals r squared, right? But remember we said on our unit circle, x is cosine, y is sine, and r is always what on our unit circle? Well, our r is always 1. So, now I'm not real sure why they always write sine first since it's x squared plus y squared, but order doesn't matter when we're adding. So we get sine squared plus cosine squared equals 1. And the cosine squared came from the x squared, sine squared came from the y squared, and remember our radius on the unit circle is 1, and 1 squared is just 1. Now, I'm going to use example 1 down here to help us on this. So, if you know the basic identity, it's easy to get the other 2 that come from it. So, I give you this ordered pair on this terminal side here, and it's an ordered pair, remember, it's an x and a y. And so we know that this is going to be our cosine, and this is going to be our sine, because they're x and y and they're on the unit circle, which has a radius of, hopefully you thought 1. Alright, so we know from here that x squared plus y squared equals 1. And so from that, remember we had said we got that sine squared plus cosine squared equals 1. That's where we got the first one that we wrote up there. Now, what would happen if I took that trig function right there, now remember, as long as I do the same thing all the way across the function, it's still equal. So what if I took that trig function right there and divided everything by sine squared? So here's the original one, sine squared of theta plus cosine squared of theta equals 1. But what if I divided every single thing here by sine squared of theta? Well, we know sine squared divided by itself would be 1 plus cosine squared over sine squared. Now that comes from those identities above. We know that cosine over sine is cotangent, so this is going to give us cotangent squared of theta equals 1 over sine squared is one of my reciprocal identities, and so that would be cosecant squared of theta. So here is another identity that we got from this first one. So we also have 1 plus cotangent squared of theta is equal to cosecant squared of theta. Now, you probably still have a little bit of room on example 1 there, but I'm out. So if you need to finish writing that, pause this because I'm about to erase what I have there so I can figure out the last one. Alright, so for the third one, what if I took this original one, sine squared plus cosine squared equals 1, and I took all 3 terms here, and what if I divided them all by cosine squared this time? Remember, as long as what I do to one I do to all, this is still equal. Well, sine squared divided by cosine squared, that's one of those quotient identities from above. Sine over cosine is tangent, and since these are both squared, we're going to put tangent squared. Plus cosine squared divided by itself, anything divided by itself is 1, equals, and then 1 over cosine squared, you can look above in your reciprocal identities, and we know that that is secant squared. And so here is our third Pythagorean identity. And so we're going to add that up here to our group. So we get tangent squared of theta plus 1 equals secant squared of theta. Now I'm going to advise you to put all of these on your plate. If you end up trying to memorize them, guys, on this one, all you really have to do is memorize the first one because you know how to find the other 2 from it. But my advice is get it on your plate ASAP. All of them, not just these 3, but all of the ones above as well.